And it's recording. All right, today's lesson is more of an intro coming back in term 4, so it's just reviewing what you should already know. So let's see what you remember from your previous years. Review of probability, chapter 8, 8A. Trial is a...
Multiple. Continuous.
Exciting.
Am I on the right track? It's experiment.
It is a single experiment.
I thought it's like multiple. It's okay.
No, trials is then multiple. For example, what is a single experiment? It is something like flipping a coin. That's one flip. Rolling a dice. Spinning a spinner. These are examples of a single experiment. So it's a trial. An outcome is a possible result. Very good. Is a possible result from an experiment. So when you flip a coin, you get a result. You roll a dice, you get a result. And you spin a spinner, you get a result from the experiment. Sample space is the list of possible outcomes. Very good. What did you say? List of outcomes. Which is true, right? It is a list of outcomes. We're more specific. Possible outcomes. Event is a collection of focused or observed or favorable is the general language that we use. Favorable outcomes.
What's favorable outcome?
It's the ones that you want, desirable. Usually they say probabilities like number of favorable outcomes over total number of outcomes. That's why they say favorable. All right, next one. Difference between listening. Experimental probability versus theoretical probability is one is based on yes.
Favorable, and the other is the number, I think.
One of them is going to be a random one.
Favorable and positive. Favorable and focused.
Well, I guess as long as you know the difference, I mean, there's a lot of different words to describe this. Listening? Boys. Samuel. Yeah, so the idea is to understand the difference between the two is that one outcome is actually happening. Okay, so it's based on real outcomes, and one is a possible or hypothetical outcome. So an experimental outcome is one that actually happens. So if I asked you all right now, for example, if I asked you to flip a coin 10 times, 10 times, the reality is that each of you will get a different set of 10. Some of you may get 3 heads and then 7 tails. Some of you may get 1 head and then 9 tails. Some of you may all get 10 heads and 0 tails. That's the reality because each one is going to change. Okay, so this is what is based on, I'll normally call like real or current outcomes, and the other one is hypothetical. Well, it's more of a longitudinal perspective. The idea is that if I asked you, out of 10, if we flipped coin, and I asked you, how many do you expect to be tails, and then how many should be heads, you would say? 50-50, which means 5 heads, 5 tails, right? So this is what we think theoretically should happen, but reality, it's different. However, if you took your experimental probability and you did it in a longitudinal study, so if you went on to 1,000 flips, to 1,000,000 flips, to 1,000,000,000 flips, the overall percentage actually starts to plateau to 50-50. That's why we say in the long term, if we were able to do it indefinitely, then yes, it does work out to be 50-50. But when you do it on a smaller scale, like 10 flips, then it varies hugely. Okay, so one of the reasons why on a huger scale, why does it balance out? It's because when you lose out on, like for example, a test, if you think about it realistically, I've made a test that's only out of 10 marks. 1 mark that you loses a lot of percentage. But if I had a test that was out of 1 trillion marks, right, then one mark off doesn't actually make that different. So it makes it very insignificant. So you'd have to have a huge loss in order for your percentage to actually get affected. That's why in the long term, it actually plateaus out to 50-50 because the one change or one flip that you made wrong or different doesn't actually affect the percentage hugely. So the larger the trials you do, the more stable the probability is. So that's why we call it theoretical versus experimental. And it also changes the way you think when it comes to probability, theoretical versus experimental later on. Okay? But that's the main difference. So at the year 8, year 9, year 10, junior levels, you just need to know the difference. And then when you get to year 11 and 12, we talk about theoretical versus experimental more deeply. Okay? And hence there's more formulas involved. All right. So those are the basic terms for 8A. Let's have a look at some basic questions. Example 1. A letter is chosen from the word calculation. So this is the word calculation. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters there. Find the probability that the letter is a letter T. Now, I don't want you. Okay, now I don't want you to just write 1 out of 11. I want you to write the proper notation for it. How do you write probability again? Capital P, little r. Make sure to use the brackets. And in this case, I want the probability of getting a T. So I put T. That's called the event. This is called the event. This stands for probability. So the notation, when you write that, that means the chances of getting the event T, so what I'm focused on is I want to get T, is equal to 1 out of 11. That's what I want you to practice. So using the correct notation, it's capital PR for chances of getting, and then the event. So you can write it as a descriptor. You can say the chance of getting a letter T, so a letter T in the brackets, but in this case, I'll use a capital T for it. Okay? Next one, getting a letter A. So in this case, again, you would use PR of, and you can use a descriptor. You can say a letter A. Sometimes in year 12, they can use a descriptor because the information gets a bit more specific. So they have to actually write in the event, but you can write just the letter A in this case. So probability of getting a letter A is equal to, what is this? 2 out of 11. So this is your favorable outcome. So it's the observed. And then this is the number or sample space. Okay? So I'm just breaking it all apart into the language we use, favorable outcomes over total number of outcomes, which really just means sample space. Anyone remember the notation for when you say letter not an A? So we've got PR of A before. How do I say not A? Very good. Apostrophe, this is called dash. What's the proper name for that dash? Anyone remember, starting with C? Complement. Not like the compliment that you get when someone's flattering you. It's complement, not compliment. So LE. So that's a complement. Complementary event. Good. Complementary event. Oh, very good. That's the next one I was going to ask. So probability of getting not A should be the left over. So 8 out of 11, because if it's 2 out of 11 to get A, then not A must be 8 out of 11. Oh, sorry, 9 out of 11. My bad. Can't count. Next one. I bolded the word or because you have to know the notation for or. It's PR of. Now you want to say A or T. So what symbol do you use? Union.
Oh, wait, hang on. What if it's a question where D is a letter A, not A or T? Then do you put it in color or both?
Then you do, wait, not A or T? Or just not A?
Not A or T. So it would be
Yeah, then
A.
there will be A union T.
Why not A complement U?
So then this one would be not A, union with T.
And then that
Or you could do it this way.
It's just simplified. When you put it outside the bracket.
Well, they could mean different things actually. Now I think about it. Not A, so this is where we're going to practice. So A, not A is everything outside. Or not T, so pretty much you color everything except for the center. Whereas if we did it the other way, if we did A union T, that means, no, so they're different. So this is AT, that's A union T, so if you say not A union T, it means everything outside. So actually they're two different ones, so it depends on which one you meant before. Yeah. So this one means not A, so not A is this region, so not A, so color everything that's not A. And then not T is everything this region. So the only one that I'm not coloring is the center. Whereas the one I just did there, this one is A union T, and then the yellow is not that. So this is that's A union T, not A union T, which is this one. This one is saying color all everything that's not A, then color everything that's not T. So you can see the one that I didn't get to color was the center, so they're two very different. So it depends on the language on what you're trying to
That one's
say.
saying not A or T. The one with the brackets.
Not A or not T.
No, the bottom one.
The bottom, this one.
No, the bottom one is that one.
That one means that if you grouped A and T together, I don't want
Yeah.
them.
Yeah.
So it means this first step is you group them, and then you said, I don't want that group. Whereas this one's saying, I don't want A's, and I want you to group with not T's. So that's a different step.
Wait, so I'm trying to find the one like C, L, C, U, one like it's got calculation. I didn't want A's and T's at all.
Yeah, so then you're saying, yeah, the first one. You say, I don't want A's, or I don't want T's. I don't want A grouped with T. So A or T, but then, sorry. I want A and T, or A or T, and then I don't want that entire group of people. Whereas the first one, you already excluded a group. You said, I don't want A's, and then I don't want T's. Tell me who those are. Whereas the first one, you grouped all the A's and T's together, and then you say, all right, that's the group I don't want.
But then that one was like, I don't want A's or I don't want T's. Why highlight the outside part? Is that not A or T?
Which one? This one?
The top one, the yellow one.
Yeah, so the first one you said group A and T's together. So here's my group A, here's my group T, and then you say, now I want the people that aren't in that group, which is the yellow region. Whereas this one you said, I don't want A's. Sorry, not A's is this one. So I'm going to color that. That's not A's. And then you also said, I also don't want T's. So I color all the things that aren't T's. So overall, you colored everything, but the only people you didn't exclude is the center.
Okay.
Yeah, that's why it's different.
Thank you.
That's a good question, and that's what you got to practice learning. Did you want me to keep that? I'll keep it there. Well, I don't know what I did. All right, team. On to the next notes. Oh, sorry, I didn't answer this question. This one was A union T. So all of A versus T. So how many A's and how many T's? 1, 2, 3. So it should be 3 out of 11. We good? Next one. Flip over the page. Last example for today. Here we go. An experiment involves checking second-hand bicycles for faults. Here are the results after checking 100 bicycles. So the number of faults on a bicycle. So let's say you've got 0 faults. You've got 10 of them. 1 fault, there's 32. 2 faults, 45. 3 faults, 9. And then 4 faults is only 4. So out of 100, so it means if I added 10, 32, 45, 9, and 4 should give me 100 bikes. First one, find the experimental probability that a randomly selected bicycle will have 0 faults. So in this case, you would do probability 0 faults is equal to 10 bicycles, because we can see there are 10 bicycles out of the 100. Don't leave your answers 10 out of 100. You must simplify to 1 out of 10. You don't do that, you lose a mark. Next one. 3 faults is probability of 3. So number of faults, so 3. How many is 3? That's 9 out of 100. Leave your answer there since there's nothing to simplify. Let's get on to some harder questions. Fewer than 3 faults. So in this case here, you're saying probability of less than 3 faults. What's the chances of getting less than 3 faults here? Can I please have... Let's go, Toby. To get less than 3 faults, according to the table, how many bikes will have less than 3 faults? Very good. So that's what? 42 plus 45 is 87. 87 out of 100. Very good. Next one. Probability of at least 1 fault. So greater than or equal to 1. Now you can do 1 or more, so 32 plus 45 plus 9 plus 4, but what's a quicker way? Very good. So this is called taking the total, which is 100, 100% minus the chances of getting not what you want. So it would have been quicker if you did 1 minus the chances of getting 0, because greater than or equal to 1 is the same thing as saying finding less than 1. So it'll be 1 minus 10 over 100, and you get 90 over 100. Very good. Oh, that's it. That's the last one. So that's as hard as it gets. That's exercise 8A. That's a bit of revision on terminology and notation. I'm going to stop the video.